Hello, this is Math 1120 coming to you from the College of DuPage, and this lecture is entitled Probability Introduction. So probability is a function. Just like f of x, this is p of e, but instead of putting a number in here like x, you put an event. So the probability of any event, p of e, must be greater than or equal to 0 and less than or equal to 1. And this is the inequality representing those facts. And if you add up the probability of all outcomes, it must be 1. That is, if the sample space is E1, E2, En, then the probability of each of these discrete events is equal to. So a probability model lists the possible outcomes of a probability experiment and each outcome's probability. A probability model must satisfy both of the rules that I listed in order to be a probability model. Here's an example of a probability model. Here you see the color of various kinds of M&Ms and the probability that there is an M&M of that color. This is a probability distribution because the probabilities are all between 0 and 1 inclusive, and because if you add them up, they add to 1. If an event is impossible, the probability of the event is 0. If the event is a certainty, the probability of the event is 1. An unusual event is one that doesn't occur very often, and in this class, that will be 5% or less of the time it happens. And if you do an experiment and you want to approximate the probability, you'll say that P of E is the relative frequency of E happening. And that's going to be the frequency of E happening in your experiment divided by the number of trials of the experiment. So here's an example, and they're playing a dice game, and there are 6 possible outcomes, and what they do is they roll the dice almost 4,000 times, and they observe the following frequencies in their experiment. So then they added them all up, and they used that to determine the probability. And they ask, is it unusual to throw a leaning jowler? Well, you divide. These are relative things, so there were 39 tosses, and so these are the probabilities, and you do all this, and you can see that 8 times out of 1,000 you get a leaning jowler, so that is unusual because it's less than 5%. And so these are the probabilities, and so I could ask you a question like this, but the probability to throw be a side with a dot is 0.329. And a leaning jowler is unusual and gives you that thing as well. Okay, so now you can do this not only with an experiment, but you can say, let's pretend they're equally likely outcomes. This is what we did in the dice experiment in the VCM lecture. And so you have equal likely outcomes when each simple event has the same probability of occurring. So in the dice problem, we're assuming that the dice are fair die. And so you would calculate the number of ways that E can occur divided by the number of possible outcomes. And that's actually what we did when we figured out what's the probability of getting a 7, for example. And so you count them, you take the ratio, and that is the probability. And that's what Linda did on the spreadsheet from the VCN lecture. And so if we're studying an M&M bag that has these candies in it, I ask you, what is the probability it is yellow, what is it blue, and comment on the likelihood of getting yellow versus blue. And so what you can do is pause the video and try to do this problem, then we'll look at the answer. You know what to do. Let's see how you did. Okay, and so you should have gotten to A. The probability of getting yellow was 0.2. The probability of getting blue is 0.67. And this says that the probability then of getting yellow is 3 times as likely as selecting a blue. Now we're also going to talk about using simulation to obtain data based on probabilities. And we're going to do an experiment with simulation in tonight's VCN lecture. We're videotaping that for everybody, and you should watch that. This is an important topic.